25th, once again, 8.G.3, 8.G.4. Somebody read that standard to us today.
I can identify when a dilation has occurred with 60% mastery.
Good job. On last week, we talked about transformations. Can anybody tell us anything that you learned last week about transformation?
Flip.
Say what, Cora?
Flip.
What's the correct name for that?
Rotate.
A rotate ain't a flip.
Wait, say it again.
Angela said, I said, what's the correct name for what you said, flip? That's what lower elementary use.
Reflection.
Good job. Thank you, ma'am. Reflection. Somebody said rotation. We missing one.
Translation.
Good job. Those were the 3 types we talked about on last week. And with those 3 types on last week, who remembers what kinds of shapes we would get?
Triangles.
So the only thing we dealt with was triangles.
Oh, no, yeah.
I'm talking about if I rotate a figure, if I slide a figure, if I flip that figure, how would that figure still look? I don't remember. You look in the mirror. Did you lose any hair?
No.
Okay, so if nothing happened to it, that means we get what kind of figures? Thank you, Jacob. We get congruent figures. So today we're going to learn about dilation. Dilation is that 4th kind of transformation. It's the one that we're not always going to get congruent figures. We'll get those similar figures. And those are figures that have the same size. It's the same shape. However, it's going to be a different size. And dilation figure can be increased or decreased. Scale factor. Somebody read what a scale factor is.
The ratio of the length of a side of the image to the length of the corresponding side of the original figure.
Remember what corresponding sides are. What do we learn or say about corresponding sides? Scale factor is a ratio. What does a ratio look like? Write a ratio 3 different ways. Let's finish reading the next piece.
Multiply coordinates by the same scale factor to find new coordinates of it.
Good job, thank you, ma'am. So it pretty much works the same as equivalent fractions, something that we learned many years ago. Center of dilation, somebody read it to us.
One that is transformed to itself by this thing. One that is transformed by itself by dilation.
Thank you. It's the point that is transformed to itself by the dilation. So just like with the 3 we learned last week, all the time the ones don't change. Sometimes they do. All of them don't change at once, especially if dealing with the origin. All right, somebody read that to us.
Dilation can occur with other transformations.
Good job, thank you, sir. Dilations can occur with other transformations. Now, I just stated that dilation means the figure would get larger or to get smaller. So you would instantly know if those two figures have a dilation because one would clearly be a different size. All right, someone read that to us.
Scale factors less than 1, figure is decreased. Scale factor of 1 or greater, figure is enlarged.
So the scale factor can pretty much let you know what kind of figure you're going to get before you even find those other coordinates, just by noticing what that scale factor would be. All right, everyone should know how to find your practice in Schoology. Those of you that don't have access to Schoology, you should find yours in Google Classroom. Everybody else is in Schoology. About a minute to get there. Those who never went to Schoology, I did just put it in the chat box. With that web address, you won't have to type in your information. It'll just let you click your circle. Lakeland, were you able to find your information in Google Classroom? All right, somebody read first example to us.
Michael is using a photo editing program to adjust the size of photos for a yearbook. To avoid distorting the image, he pulls a corner of the photo along a line as shown by the dotted line. What type of transformations transforms OAB to OCD?
All right, now what do you notice happened with that original triangle?
It enlarged.
It enlarged. So what kind of transformation deals with enlarging? All right, what are the 4 types of transformations? Okay, rotation, translation, reflection. And what was the one I told us we're looking at today?
Dilation.
Good job, thank you, ma'am. So out of those 4, which one deals with enlarging a figure?
Dilation.
Dilation.
Figure was dilated. Just like last week with when we had a rotation, we had to tell how many degrees we rotated. When there was a translation, we had to tell how many units we moved. We also have to do the same with a dilation. To help you figure out your scale factor, just pick a point. So in the smaller rectangle, someone give me a point. I can't hear you. Use the alphabet.
I said 1-1.
Yes. 1-1. Choose an alphabet, one of those vertices. A, B, C. I mean, out of 35 kids, somebody should know an alphabet.
B.
Okay, so I'm not said B. Oh, you know some alphabets now. It ain't hard. So then I'm gonna find my points at B. Where is B located at? This be y'all practice right here. This why we can't get nowhere. The more you talk, the more you learn, the more you communicate, the more we make it through.
2, 3.
2, 3. Good. What would be the corresponding point in the larger rectangle with B? Meaning what's in the same position as B, except it's in the larger rectangle. Good job, Marie. Thank you. What's the location of it?
4, 6.
4, 6. So then I ask myself, what happened to this X coordinate 2 to get 4? And then what happened to 3 to get 6? What was multiplied each time? Good job. I got you, Lakeland. All right, so it moved by 2. So we would then say the figure was dilated with a scale factor of 2. And I know it would have to be a number larger than 1 because the figure was enlarged. Any questions about it? Anyone still need anything? All right, someone who can see. Read number 2.
Which sequence of transformations map rectangle A to rectangle B?
Good job. Which sequences? So notice it got an S on the end. So that's telling us more than one thing happened. So get in the habit of being able to recognize more than one thing happened. So let's ask ourselves with looking at A to B. First of all, what clearly happened to get to A to B? How does that figure now look? Is it the same shape and size? That's the first question you ask. All right, so if the answer is no, what kind of transformation is that telling me occurred?
Dilation.
Good job. So that means dilation would need to be one of my answer choices. Showing you how to use process of elimination. So now that we have picked out all those that would give us a dilation, which ones can I eliminate? All right, so now let's look at what's left. B says a dilation centered at the origin followed by a translation. What's a translation? Cha-cha what? To the left. Take it back now, y'all. Okay, somebody got it. Slide. So then I asked myself, could the figure get larger and then could I slide it? Listen, you laughing, but that's one way I can remember translation. I think of the cha-cha slide. Could the figure get larger or smaller, and could I slide it? Got some funny looking faces. We looking like, but all right, so let's look at our 4 types again. Rotation. What happens with a rotation? I think y'all be confusing rotation with reflection. Reflection is the one that flips, and that's the one that give you that mirror image. All right, so I guess we're gonna stay stuck on B. So let's look at C. C says a reflection in the x-axis followed by a dilation. So could it have reflected over this x-axis and then gotten larger or smaller? Look at A. Could A have reflected over this x-axis and gotten larger or smaller? All right, Lakeland, you said yes. If I reflect A, what quadrant would A be in? Got your quadrants? The quadrants, if you don't know them still. Go counterclockwise. 1, 2, 3, 4. All right, so look at where A is. A is in quadrant 1. If I reflect that over this axis, meaning if I was to fold over this x-axis, what quadrant should A be in? And like you folded on that X, you folded on that X line, where should A be? Don't even look at B. We looking at A. What quadrant should it be? Good job, Braylon. I see you. Like here, I got you. So A would then end up down here in quadrant 4. So would C work? Could it have been reflected and got larger? What else would have happened for C to happen for this rectangle to end up over here? What other kind of transformation? Good job. That would have been a dilation. Translation. Good, good. All right, then look at E. E says a rotation of 180 degrees followed by a dilation and a translation. So let's think about a rotation. On last week, we learned every turn is how many degrees? Anybody remember? Good job, it's 90. So if I turn 180 degrees, how many times did I move?
Twice.
Good job, I moved twice. So not only does that mean I moved twice, that means I moved 2 quadrants. So then I asked myself, I'm starting at A. And if I was to move 2 quadrants, could I end up down here in B?
No.
Go back to A and move 2 quadrants and ask yourself, can you be in quadrant 3? Yes. Somebody said no. Watch your counting now. We only moved 2. So that's a possibility. And then they said it dilated and then it translated. Could all of that have happened to get from A to B? All right, think about it. A is up here. You already said we moved 2 quadrants. So A came to quadrant 3, and then A got smaller, and then they saying it was slid over some. Could that have happened? Not necessarily, Omar. Translation just means 1 unit. It could have just translated 1 unit up, 1 unit down, but not necessarily pushing it out of that quadrant. The only way it's guaranteed to be pushed out of that quadrant is if a rotation happens. But a translation can just move it up just a little bit. So E can happen. Are we sticking with B or are we getting rid of B? And 2 things could have happened. They slid from A down here in quadrant 3, and then it got smaller. Could that have happened?
Yes.
Yes. So the 2 answers you should have are B and E. Y'all make this harder than what it is. The 4 easy things to know: flip, turn, and slide. That's it. You know them. Got bigger or smaller. You can easily pinpoint those. Don't make these big words harder than what they are. You just gotta, like I say, think of something when you think about it. Any questions about number 2? All right. Anyone still need anything? All right. Somebody read number 3 too.
Amy and Dilates triangle PQR shown on the coordinate grid with the scale factor of 0.5 censored at the origin. Then he translates the image 1 unit up and 3 units to the right from triangle PQR. What are the coordinates of the vertex of triangle PQR?
How many transformations did they tell us about? 2. What's the first one? Dilation. And they said that was with a scale factor of what?
.5 centered.
Good job. Thank you, man. So before we can even find those final points, we first got to get those original points. So looking at this chart, what are the coordinates of P, Q, and R?
P -6, 4.
Good job. Thank you, sir.
Q2, 8.
And I think that's the one Jeremy had just put in a notice. All right. All right, and Amara said 2, -4 for R. Good. So the first thing we said happened was a dilation with a scale factor of 0.5. Now earlier, what did we say? What operation did we do when there's a scale factor? Good job. Thank you, Jacob. We multiply. Anytime I see scale factor, I multiply. So with these coordinates we have, we are multiplying the x coordinate and the y coordinate by 0.5 for each. So if we do that first for P, what are our new points for P? Take half of both. Half of -6 and half of 4. I shouldn't be waiting this long for somebody to tell me half. Thank you. -3, 2, Q. All right, and R. Check that. -2, check that. That's it. All right. Not only would I do that, I would also point them to C. Tell you all the time it is a math class. You should have a little paper and pencil so you're able to follow along, see what's happening. All right, so that was the first transformation. What was the second transformation?
Dilation.
Oh, that was the first one. That was the one we just did. Translation. What kind of translation? What we doing? One up, 3 to the right. Now we're talking about up. What axis go up? All right, and if I'm going up, would that be positive or would that be negative? Good job. So that means my y coordinate, we're going to add 1 to it because we went up. Right. So if that was y, this must be x. Would I add or would I subtract if I'm going right? Good job. We would add. So our x coordinate, we would add 3. So from the last coordinates, now we get this second transformation. So now, if I add 1 to y, 2 plus 1 would give me 3. And then I would add 3 to x. New location, 0, 3. All right, Q, 4, 5 is that's one you're giving me for Q. And then I see 4, 1. And let's see. Look off. Or is it my drawing that's off? Check our points. 2 plus 1 was 3. -3 plus 3 is 0. 4 plus 1, 5. That make my points just off. Look at R. -2 plus 1. Would that be a positive 1? Good job.
Negative.
Good. So that's why I say it's always good to kind of draw. That way you have a visual that'll let you know if you're on the right track. Like I instantly noticed, hey, that triangle did not look the same. So those are key things for you to take note of. All right, and so those will be our new coordinates. Those are the coordinates they want from that second transformation. So some of these problems you may have to read 2 or more times just to make sure you understood it correctly or did the correct rule to get the correct coordinates. Any questions about it? Anyone still need anything? All right, so I'm reading number 4 to us.
A linear transform figure 1 to figure 2 is shown. Which statement accurately describes a linear transformation?
All right, so we went from 1 to 2. All right, A says they're similar, B says congruent, C says a rotation, reflection, and a translation, D said congruent because of a dilation. What happened? Or what can we say about these two figures? It's only two words that repeat: congruent, similar. I mean, and we shouldn't be sitting here waiting on congruent and similar. All right, so if it was dilated, there you go. It was dilated, he says not congruent, so that means they are similar. That's what similar means. So that means if you still haven't learned that about similar, that need to be in your math notebook. When you see it, you should instantly put similar with a dilation. That's the only one that's going to give us a different looking figure. Any questions about it? All right, somebody read number 5 to us.
Describe two sequences of transformations that map figure ABCD onto figure EFGH.
Good job. Thank you, Lakeland. All right, so looking at these two figures, they said figure ABCD. So clearly that came first. So I told us last week, if you need to label your shapes to know, okay, you did this first, do so. So looking at 1 and figure 2, what would you say was one transformation? Rotation? I don't know about a rotation. I might agree with a reflection. A reflection across what axis? Good job. Reflection across the x-axis. That's one. The second thing that could happen. All right, Amara, you said the figure was translated 1 unit to the right, 1 unit down, 2, and reflected over x-axis, then dilated. All right, so you're saying 3. Said it could have been reflected. Said it could have been translated. And you said it could have been dilated. All right. Amara, one I would take out would possibly be the translation. And one reason I say that is being the dilation happened. So that could be the reason why there's a gap in between the coordinates because it did get larger. I like your thinking. All right, as always, I'll be trying my best to make it through your practice. We get through a little bit. We have some who be trying to push us through it. We may have made it through half of it today. It is already in Schoology as well as Google Classroom. So if you were not working with us, make sure you go back later. And do not forget, if you did not submit the attempt, don't forget when you go back later to not forget to submit it. Some of you have a lot of assignments in Schoology that are in progress. That means you did not submit that attempt. I can't grade it if it's in progress. So if you have finished some of those assignments, just make sure you go back and submit them. And as always, if you have any questions and concerns for me, everyone should know how to reach me. Have a great Monday. Wake up.